Hey everyone, ready to dive deep. Today we're tackling AI. But not just any AI, we're talking about AI that can move and interact with the real world. Like robots doing parkour, not just sitting there playing chess.
Exactly. It's a whole different ballgame. We're moving beyond the classic Turing test, which was all about conversation, and stepping into the realm of an embodied Turing test.
So AI that can actually be in the world, not just chat about it. I've been looking at some papers from some real experts, Zador, Ren, and Xia, and Fan and their team, and they all point to this gap between how AI works now and true intelligence. Like that whole mind-body connection we humans have.
It's a key difference for sure. I mean, a computer might wipe the floor with a chess grandmaster, but ask it to actually set up the board, pick up the pieces. Zador's team uses that example to show how AI might be great at abstract thought, but it often lacks that sensor-motor knowledge that we get from actually being in the world.
Sensoromotor knowledge. Okay, so it's like our brains use our senses and movements to understand how things work, right? Like how a chair feels, how to walk without falling over.
Exactly. It's integrating information from our senses, sight, touch, sound, with our actions to make sense of our surroundings. And that's something AI is really struggling with right now.
So it's not just knowing the rules of chess. It's about understanding how the pieces feel, how they move on the board. That makes me think of Zador's example of the self-driving car and the falling crate.
Oh, yeah. Good one.
A human driver would probably just swerve a little or slow down, but an AI might see that crate as a massive obstacle and slam on the brakes, maybe even cause an accident. It's missing that common sense we humans have, which comes from years of, well, bumping into things and figuring stuff out.
Exactly. So how do we bridge this gap? How do we get AI out of the digital world and into the real world where it can learn this crucial sensoromotor knowledge? That's where the research gets really interesting.
Yeah, like how do we teach a robot to learn like a baby?
Well, scientists are taking inspiration from the brain itself. They're trying to understand how biological systems, like us, develop these amazing sensoromotor skills.
So instead of just programming AI, we're trying to understand how our own brains work and then use that to build smarter machines, kind of like reverse engineering intelligence.
You got it. And robotics is a big part of this. Researchers are working on robots that can move with the grace and flexibility of, say, a squirrel running through the trees. It's about mimicking the fluidity and intelligence of natural movement.
That's pretty wild. I mean, how do you even program a robot to move like a squirrel? It seems so complex.
Well, that's where the insights from neuroscience come in. For instance, both Zador and Ren and Xia talk about this concept of partial autonomy in the brain. Our brains don't have to consciously control every single muscle when we walk or pick something up. There are lower-level systems that handle those routine actions.
So it's like our brains are delegating tasks. Pretty efficient.
Exactly. And researchers are trying to replicate this in robots, creating systems where lower-level modules can act independently. This frees up the higher-level systems to focus on the more complex stuff, like planning and decision-making.
So giving robots a bit of that subconscious movement we take for granted. I see how this all ties back to the embodied Turing test. If we want AI to truly pass as human, it needs to move and interact with the world naturally, not like some clunky robot.
Absolutely. And it's not just about passing some test, it's about understanding what intelligence really is. And that understanding is changing fast. The more we learn about the brain, the more we see that intelligence isn't just about thinking. It's about our bodies, our experiences, our interactions with the world. And that's the exciting frontier that AI is starting to explore.
This is pretty mind-blowing stuff. We've covered a lot of ground here, from the limits of AI as it is now to the potential of these brain-inspired robots. And it all points back to this idea of an embodied Turing test. Not just thinking like us, but actually being in the world like us. But this is just the beginning. There's a whole universe of questions still out there.
And as we, dig deeper into embodied AI, we start to see some really cool stuff happening with the brain. And it's not just about the structure and the way it's organized. It's about the basic building blocks, the neurons themselves.
I gotta admit, I always thought a neuron was just, well, a neuron. But now I'm hearing about all these different types of neurons. What's up with that?
That's a great question. The brain, the human brain, it's incredibly complex, right? It's not just this massive identical neurons, like a bunch of clones. It's more like, think of it like an orchestra.
Oh, I like that.
You got violins, cellos, flutes, trumpets, all working together to create this beautiful music.
So different types of neurons, they're like different instruments in the brain's orchestra, each one playing its own part.
That's it. And just like different instruments make different sounds, different neurons do different computational tasks. And this diversity, this is one of the things that makes the brain so powerful.
So are you saying our current AI is kind of missing out on this whole neuronal diversity thing?
That's exactly what Fan and his team are getting at. They argue that our current AI models, they use a really simplified, like one-size-fits-all type of neuron. It's like trying to play a symphony with just one instrument. Imagine an orchestra of just bassoons.
Yeah, that'd get old pretty fast.
Hmm.
So how do we bring this neuronal diversity into AI? I mean, how do you even translate the complexity of a real neuron into a computer system?
It's a challenge, that's for sure. But Fan's team is exploring some pretty cool approaches. One is to develop artificial neurons that, more closely resemble real neurons in terms of their electrical and computational properties.
Oh.
For example, some neurons in the brain, they don't just do their calculations in the cell body, they actually do a lot of processing in the dendrites.
Hold on, dendrites.
Yeah, those are the branch-like structures that receive signals from other neurons.
So it's not just a simple input-output system. There's a whole network of processing going on inside each neuron.
You got it. And if we can figure out how to incorporate these dendritic computations into artificial neurons, well, who knows what kind of crazy computational power we might unlock.
That's mind-boggling. It's like upgrading from a calculator to a supercomputer, just by copying the way real neurons work.
And it goes even deeper than that. Remember when we were talking about sensor and motor knowledge? Well, real neurons have this amazing ability to take different types of physical signals from the world, like light, sound, pressure, even chemicals, and translate them into electrical signals.
Signal transduction, right. It's like the input stage of the neuron, converting real-world information into the language of the brain.
Bingo. And right now, most AI systems are stuck processing digital data, ones and zeros, images, text. But if we want AI to really interact with the world like we do, it needs to be able to sense and interpret that same rich tapestry of signals.
So we're talking about building AI that's more like a sensory being, not just a data-crunching machine. That makes me think about the embodied Turing test again. If we can create AI that senses the world as richly as we do, that takes us a big step closer to passing that test.
Absolutely. Imagine a robot that can not only see an object, but also feel its texture, its temperature, even how heavy it is. That's the kind of richness we experience as humans, and it's critical for understanding the world.
It's like giving AI the ability to truly experience the world, not just process data about it. And that opens up a whole other can of worms, doesn't it?
You said it. Because once AI starts to experience the world in a more human-like way, those lines between machine and human intelligence get even blurrier. It makes you wonder, what does it even mean to be intelligent? To be conscious?
This is getting pretty deep. We've gone from parkour robots to pondering the nature of consciousness.
Well, that's the thing about embodied AI, right? It's not just about robotics or computer science. It's about neuroscience. It's about philosophy. All these fields, they're all connected.
It's a big web for sure. And at the center of it all is this idea of the embodied Turing test, which isn't just some thought experiment anymore. It's pushing the boundaries of what AI can do, making us rethink what it means to be intelligent.
It's a powerful reminder that true intelligence, it's not just about thinking. It's about perceiving. It's about moving. It's about interacting with the world. It's about being embodied.
So much to think about. We've covered a lot of ground here, from those tiny neurons to these big philosophical questions about AI experiencing the world. Okay, so we've gone pretty deep into how embodied AI works, from the brain to the robots. But where does all this lead? What's the big picture?
Well, I think the potential here is huge. For a long time, AI research was all about copying how the human mind thinks, like logic, problem solving, winning at chess. But now we're starting to understand that real intelligence is a lot more than that. It's about sensing, moving, interacting with the world. Like you were saying earlier, it's about being embodied.
Right. And if we think about AI that way, it opens up all sorts of possibilities. It's not just AI beating us at games, it's AI working with us, helping us solve big problems.
Exactly. Imagine robots that can explore places that are too dangerous for us, like the deep ocean or even other planets.
Like in those sci-fi movies.
Yeah. They could be our eyes and ears in these extreme environments, gathering data, helping us understand the universe better.
That's pretty amazing. And what about things here on Earth?
Oh, tons of possibilities. I mean, think about robots working alongside surgeons in hospitals or helping out on construction sites, doing the dangerous jobs.
That makes sense. But what about jobs in general? If robots start doing all the things humans do now, wouldn't that lead to a lot of unemployment?
It's a good question. And yeah, it's something we need to think about carefully. Some jobs will definitely be automated as AI gets smarter. But we also have to remember that new technology often creates new jobs too.
So it's not necessarily about robots replacing people, but about robots and people working together.
Yeah, that's the idea. Each side using their strengths.
Okay, I can see that. But what about the ethics of all this? As AI gets more embodied and starts making more decisions on its own, how do we make sure it's doing the right thing? Making choices that align with human values.
Another great point, and a big focus in AI research right now. The key is to develop AI that is transparent, accountable, aligned with human ethics. We have to build in safeguards from the start, make sure humans are always in control.
So it's not just about building smart machines, it's about building responsible ones, machines that are actually good for society.
Exactly. We have a responsibility to make sure AI is used for good, not for harm. And that takes planning, collaboration, and a lot of discussion about the ethics of this powerful technology.
This has been an amazing deep dive. We've gone from the science of embodied AI to the possibilities it opens up, all the way to the ethical challenges. It's clear we're just at the beginning of all this, with so much more to learn.
Absolutely. It's a rapidly evolving field, and it's going to be exciting to see where it leads.
Definitely. Thanks for joining us on this journey into the world of embodied AI. Until next time, keep exploring and keep asking questions. The future is full of possibilities.